Hello, I'm Hazel Henderson. Welcome to Ethical Markets and our series on transforming finance. Today we're talking about investing in desert greening. We must all look deeper if we're going to protect our retirement assets from the almost inevitable next meltdown. Today we're meeting with two world-class scientists who have explored the way we humans can grow food, fiber, and edible oils, as well as biofuels, from cultivating the 10,000 species of salt-loving halophyte plants, which thrive in desert areas, irrigated only by seawater. I'm honored to welcome Dr. Dennis Bushnell, Chief Scientist of NASA, based in Langley, Virginia, and Dr. Carl Hodges, President of the Seawater Foundation, which has been conducting seawater agriculture in many Mideast countries. Dr. Hodges, Dr. Bushnell, welcome to you both.
Glad to be here. Thank you.
So, Dr. Bushnell, why don't you start off with the perspective from NASA, our space agency, and how you see salt-loving plants and the resources that we are wasting, i.e. sunshine, desert land, and seawater, and how we can put together a new kind of food supply for humans.
Okay. The humans, unfortunately, have been too successful. We have just about outrun the ecosystem. The ecosystem, much of it is in fact crashing. We're short about 40% of a planet, and so it's important if we're going to keep growth as the economic mantra to somehow make better use of some of our resources. Two particular resources that we have a surfeit of is seawater. 97% of the available water on the planet is seawater, and desert land and wastelands. Currently, 44% of the land mass on the planet is in fact deserts and wastelands. How do we use these two massively large capabilities, assets? And the answer to that is to look at the plant kingdom, which is broken up into glycophytes and halophytes. Glycophytes are freshwater plants and halophytes are saltwater plants. People, when they talk about biomass, when they talk about plant kingdom, they look outside their window and they see glycophytes. Almost all of the agriculture on the world is based upon glycophytes. These are freshwater plants. 3% of the water only is freshwater. We're running out of fresh water. So there's another whole half of the plant kingdom which are halophytes, and these are the salt-loving plants that our hostess mentioned. So the halophytes can actually grow in desert areas. They can grow using seawater or saline water. And what's nice about seawater is it contains many trace minerals which we have exhausted out of the conventional agriculture that we're now doing. And we need these within the human diet. There's recent studies highlighting this. And also, seawater contains about 80% of the nutrients that plants need to grow. And so you have water, you have minerals, you have land, and this is land which is quite inexpensive. I mean, you can buy an acre of land in the middle of the Sahara fairly inexpensive. Okay, so one can now take and think about what's the capacity of switching to a halophyte agriculture, and the capacity is just immense because this is now 44% of the land mass. Bringing that into production, which will greatly alleviate the overall pressure upon the ecosystem. If you did something simple like plowed up the Sahara, irrigated it with the Mediterranean, and grew halophytes, you could grow enough biomass to replace all of the fossil carbon fuels. You could grow enough biomass to produce all of the petrochemical feedstock you need for all the plastics, and you could produce food. And to the extent that you use salt water to produce food, you then release a large part of the 68% of the fresh water that's now used for conventional agriculture. So, and as the biomass is used for producing energy, this is almost a closed CO2 cycle, except for the fact that the halophytes actually sequester CO2 in the roots, so it's better than a closed CO2 cycle. You can end up then solving literally land, because you're bringing much more productive land into use. Water, because you're replacing fresh water for food production. Food, because you're producing food. Climate, because this is almost a closed CO2 cycle, so you can do away with the conventional carbon fuels. And energy, because you're supplying energy, and the amount of energy we're going to need going forward is only going to increase as the population increases.
We also have Carl Hodges here, and Dr. Hodges has been doing all of this. So, Carl.
Dennis talked about looking out the window. I grew up in Phoenix, Arizona, where we didn't have any beach, but we had a lot of desert. And we had a lot of beach, little water. Water was a problem. And during the days of the Kennedy administration, I designed a solar distillation facility that we built in Mexico with a Mexican university. I was at the University of Arizona, and I thought we'd desalt the oceans and make the deserts bloom. Well, we could desalt seawater, and we supplied water to the community and so on, but plants use a lot of water. As Dennis just pointed out, 67% of the fresh water we use is for irrigation of freshwater plants. But in the process, I moved to Mexico, lived in a small little trailer, and I walked in the estuaries and saw all these plants that grew on seawater. And I thought, looking out of my small little window, I saw a seawater plant. And I said, why don't we domesticate these plants? I was also an atmospheric physicist and working with people that were concerned about the future, myself included. And we looked at the need for water and food and looked forward to the year 2000. And I said, well, by the year 2000, we're going to need to use seawater. Well, we're a little behind schedule, but we're getting there. And we started. We chose 700 different plants. We tried them in Mexico. We ended up choosing 20 that would give us the equivalent of soybean, wheat, rice, alfalfa, and out of the 20, we chose 3. And so in the late 90s, we went to Eritrea, Africa, where people needed help. They were supplied mostly with international food aid. They had a job, they made 30 cents a day, and they were wonderful people. I took off my tie, don't have it on today either, Dennis does. And for 4.5 years, I lived in Africa. We took a small river from the sea. We first grew shrimp and fish and mussels and clams. Then we had microalgae, which grows on seawater. We had macroalgae, which grows on seawater. And then we grew these fields of equivalent of soybean, alfalfa, etc. And we added in Eritrea the forest of mangroves. There's lots of places where this makes sense, not only from a scientific food, etc., but from a stability standpoint. The problems that you see in many countries is lack of jobs, lack of food production, etc. And this can address all those done correctly.
Yes, amazing, isn't it? I mean, we basically live in an abundant universe, don't we?
Well, we're a little short right now of resources, but there's much more that's usable with intelligent, correct applications.
Yes, if we could learn from plants how to capture those photons, those free photons every day from the sun, we would be in good shape, weren't we? I mean, that was the original technology, right? Was photosynthesis.
I think the plants started about 460 million years ago, and it took them a while. So 40 or 50 years to get to the next step is not too long, and we're there.
No, I think we're there, and just like we were talking this morning in our meeting about exponential growth that can't go on in the economy. Also, there's exponential growth, I think, in people's awareness, because we have all these technologies now of communication, and it's speeding up in a very useful way. And I have to thank both of you for this incredible pioneering work that you've been doing. And I am so happy to know that now that my tax dollars are going to NASA. Because I had always been worried, and I thought that they were all space cadets, wanting to just go to Mars and all of that, And the fact that I found you, and you were kind enough to do the foreword to this new book, this ebook of mine, it's just kind of restored my faith. And so I want to thank you both. Do you have a couple of we've got 2 minutes left, a minute each for final thoughts.
There are other benefits from this as you make a very cool surface with this irrigation. You produce fresh water on the Sahara, you put rainfall back in the Middle East and stop the desertification of the sub-Sahara.
All right.
Well, another benefit is we get to sit with Hazel Henderson. I have admired what you have done for years and years and years, and to sit with you and Dennis and talk is a great pleasure. So thank you for having us.
Well, thank you. And I want to do this again, all right? We'll find another way.
I want you to come go on a boat up a Seawater River that's running inland with me, with my grandchildren, and whoever else you want to bring.
All right. Well, again, thank you so much. It's just been such an honor and a pleasure.
Thank you, Hazel.
And so, till next time, I'm Hazel Henderson, and we'll see you soon.